Welcome to Savi YouTube channel, Sai Vidya Institute of Technology. In this lecture video, I am going to discuss the numerical problems on Bivariate PDF and CDF functions. Let us consider first problem. The problem given is the joint PDF of joint random variables x, x, y is equal to a constant c for the values of x between 0 to 3 and for the values of y between 0 to 3 and is 0 otherwise. So we have to evaluate what is the value of the constant c, what is the PDF of random variables x and random variable y, what is cumulative distribution function for joint random variables when the x and y values are in between 0 to 3. Also they asked you to evaluate the CDF value when y equal to infinity and x equal to infinity. And the last one is they asked us to verify whether the random variables x and y are independent or not. Now let us remember all the important formulas. First let us go for calculating the value of the constant c. Now from the given data, the PDF of the giant random variable x, y is f(xy) of x, y equal to a constant c for the values of x between 0 to 3 and y also in between 0 to 3 and it is 0 otherwise. To find the value of constant c, we have to use the general formula, that is the total volume under the joint PDF curve is always equal to 1. Now the given joint PDF limits is x is varying from 0 to 3, y also varying from 0 to 3. Therefore the total volume under the PDF curve is, so it is a double integral of the within the limits 0 to 3 of the given PDF. So this volume, it is always equal to 1. So from the given data, the joint PDF is equal to c for the given limits of x and y. So take c outside the integrals. Now the integral of x with respect to integral of dx and integral of dy is x and y respectively. The limit of x is 0 to 3 and the limit of y also it is 0 to 3. If I substitute the limits for both x and y, so we are going to get the value of c as c equal to 1 divided by 9. Therefore the given joint PDF can be written as f(xy) of x, y equal to, it is defined as constant c. Now we came to know the value of c is 1 by 9. Therefore the PDF value is 1 divided by 9 when the value of x and y is in between 0 to 3 and is 0 otherwise. The second unknown parameters is the PDFs for x and y. That means they asked us to evaluate the individual PDFs for random variable x and random variable y respectively. We know that the PDF for the individual random variable x is given by f(x) of x, so which is equal to, it is a differentiation of the PDF, that is a CDF of the random variable x. Now in terms of joint probability, we can express f(x) of x as it is a differential of the joint CDF for x, infinity. So therefore if I substitute the value of x f(xy) of x, infinity in terms of integrals, so we are going to get the standard relation for f(x) of x in terms of the joint PDF as f(x) of x equal to minus infinity to plus infinity f(xy) of x, y with reference to y. So this formula we can use directly to determine the individual probability density function for both random variable x as well as random variable y. Therefore the f(x) of x is integral over 0 to 3 because the given PDF limit is from 0 to 3 and for any other values the function value is 0. So the function is 1 by 9. So with respect to y we have to integrate. So it is 1 by 9 into y. The limits of the integral is 0 to 3. Therefore the f(x) of x value is 1 divided by 3. Therefore the PDF for random variable x is evaluated to be 1 divided by 3 for the limit of x in between 0 to 3, and it is 0 otherwise. Similarly, the PDF of random variable y is given by fy of y equal to the integral of the joint PDF fxy of x comma y with respect to x. Now the x limit is from 0 to 3, and the fxy of x comma y is 1 by 9. So with respect to x we have to integrate. So integral of dx is x, substitute the limits, so we are going to get fy of y equal to 1 divided by 3. Therefore the probability density function for random variable y is also equal to 1 divided by 3 for the values of y in between 0 to 3 and is 0 for any other value of y. The next unknown parameter is the CDF of the given joint PDF. They asked you to evaluate fxy of x comma y between the limits of x 0 to 3 and between the limits of y 0 to 3. So we know the general equation of CDF in terms of giant PDF as fxy of x comma y equal to integral from minus infinity to x into integral of minus infinity to y, the joint PDF integration. Now the given CDF fxy of x comma y can be evaluated as the integral over 0 to x into integral from 0 to y. The fxy of x comma y value is 1 by 9 with respect to y and x respectively. So now if we solve this integral, 1 by 9 is outside, we can take it outside. The integral of dx is x, so the upper limit is x and the lower limit is 0, it is evaluated as x, and the integral of 0 to y with respect to y is y. Since the lower limit is 0, this integral results with y. Therefore the joint CDF value is fxy of x comma y equal to x into y divided by 9 for the x range in between 0 to 3 and y range also in between 0 to 3. Therefore the joint CDF is x into y divided by 9 for the x and y values in between 0 to 3. The next unknown parameter is fxy of x comma infinity. Here the value of y is equal to infinity. Fxy of x comma infinity, it is equal to so it is the fx of x, it is equal to fx of x, or we can use the general equation minus infinity to x double integral of minus infinity to x minus infinity to the value of y is infinity. Here fxy of x comma y into dx into dy. Substitute the value of xy of xy, so that is 1 by 9. The integral of dx in the limits 0 to x is x. The integral of dy in the limits 0 to 3 is 3. Therefore fxy of x comma infinity is x divided by 3. That is fxy of x comma infinity, it is same as fx of x, so which is equal to x divided by 3 for the values of x in between 0 to 3. Similarly the fxy of infinity comma y is the value of x is infinity. Therefore the first integral limits are minus infinity to plus infinity. The second integral limits are minus infinity to y of the joint PDF fxy of x comma y is evaluated as y divided by 3 for the values of y between 0 to 3. So this fxy of infinity comma y value, it is same as fy of y. That means the joint PDF is equal to the it is joint CDF, it is equal to the individual CDF of the random variable y, and that CDF value is y divided by 3 for the values of y in between 0 to 3, and it is 0 for any other values of y. The last parameter is, so if you want to check whether the given random variables x and y, whether they are independent or not, so we have to verify the condition joint CDF whether it is equal to the product of individual CDFs, or the joint PDF must be equal to the product of the individual PDF of random variable x and random variable y. We know that from the given data the joint CDF is 1 by 9 for the values of x and y in between 0 to 3. We already found fx of x and fy of y. The value of f(x) of x is 1 divided by 3, and the value of f(y) of y is also 1 divided by 3 between the limit 0 to 3. Therefore, f(x) of x into f(y) of y will be 1 by 3 into 1 by, that is 1 by 9, for the values of x and y in between 0 to 3. So this value, it is same as the given joint PDF value, that is 1 by 9 for the x and y values in between 0 to 3. Therefore, the condition for independence is verified. That is f(xy) of x comma y is equal to the product of the individual PDFs for the random variables x and y. Therefore, the given joint probability density function is independent in nature.